Hello, everyone. Hello, hello, hello. How are you doing? So, we've got some questions and it's on differentiation. So, first question is to differentiate with respect to x e to the 3x plus ln of 2x. So, with part A, it's just doing a bit of differentiation. Oh, this pen is thin. Okay, let's change that. Yeah, this one should be a good thickness. Right, e to the 3x. Well, e to the power of something differentiates to e to the power of the same something multiplied by the derivative of the inside function, the 3x, which is 3. And then ln of something differentiates to 1 over that something multiplied by the derivative of the inner function, which is 2. So this is me doing the chain rule, but I'm just doing it quickly. Refer to my chain rule introduction videos if this is unclear. So we have 3e to the, not 2, but instead we have 3e to the 3x plus, this simplifies to just 1 over x. 2's cancel. So that's part A done. Part B, we've got 5 plus x squared to the power of 3 over 2. So again, this is another chain rule. We're going to differentiate the outside function. So this becomes 3 over 2, lots of 5 plus x squared to the power of a half. We take away 1 from the power. Then we multiply that by the derivative of the inside function. The derivative of 5 plus x squared is just 2x. And then that simplifies to, well, the 2 times 3 over 2 gives you just 3, and that's 3x. So 3x times 5 plus x squared to the power of a half. Cool. Next, go to the next question. The curve C has equation x equals 2 sine y, show that the point P, or root 2 pi over 4, lies on C. So we're just going to substitute x equals root 2 and y equals pi over 4. So does it equal each other? Well, x equals root 2, that's fine. We have 2 times sine of pi over 4. And just really, really quickly, sine of pi over 4, if you want to convert it to degrees, that's the same thing as sine of 45 degrees. Pi radians is 180, so pi over 4 is 45. So we've got the sine of 45 equals root 2 over 2. So therefore, 2 sine 45 equals 2 times root 2 over 2, which equals root 2. So root 2 is indeed equal to root 2. All good, it checks out. Part B, show that dy dx equals 1 over root 2 at P. Well, part B, this is where we use the consequence of the chain rule whereby dy dx is 1 over dx dy. So we've got this. So we can say, first of all, dx dy is equal to 2 cos y. And then dy dx, so that implies that dy dx equals 1 over dx by dy, which equals 1 over 2 cos y. Then we need to substitute, in this case, y is equal to pi over 4. So that is equal to 1 over 2 times cos pi over 4. That's 1 over 2 times cos of pi over 4 is cos of 45, which is root 2 over 2. So times root 2 over 2, which is 1 over root 2. And that is what they asked us to show. So there we go. And then with part C now, it is to work out an equation of the normal to C at P. So at P, we already know that dy dx equals 1 over root 2 because it's what we were asked to show. So therefore, the equation of the normal is going to be the negative reciprocal of 1 over root 2. So that's going to be minus root 2. So if we apply y equals mx plus c, we've got y equals minus root 2 x plus c. And our coordinate, p, because it's the normal to see at p, is root 2 pi over 4. So we've got root 2 comma pi over 4. So we substitute pi over 4 for y, and that's equal to minus root 2 times root 2 plus c. So that tells us that pi over 4 is equal to minus 2, because root 2 times root 2 is 2. So the minus goes on the outside to minus 2 plus c. So therefore, we've got that c is equal to pi over 4 plus 2. So if we've got a y equals mx plus c format, our final equation is y equals m, whereby the gradient, that should say gradient, not equation, gradient, it's going to be y equals minus root 2x plus c, which is pi over 4 plus 2. And that's it for this video, guys.